Hey everybody, how you doing, droidcon London? There was a fire on the tube, which is why I was late. So I'm just happy to be here. I'm especially, actually, I think I'm extra happy to be here with you all. Okay, I'm gonna let you know, I have a lot of content. We're 3 minutes late and lunch is next. So if you get up and walk at 12, I'm not gonna be too sad. I'm not gonna blame it on you, I'll just be sad. That's not meant to guilt you to staying. But we have a lot of fun stuff to talk about. We're just gonna get started. I'm Huyen Tue Dao. If you want some of the code that is about to come your way, there's a QR code. I'll put it up again later, but yeah. So I'm assuming that you're here because you want to learn about custom layouts. So we're just gonna get started, and we in Android love a life cycle, right? So we're gonna talk about the compose phases first, because you're gonna hear me talk about it a lot in the next 50 or so minutes, or 40. I think it's like a 40-minute talk. All right, so if you're not familiar, which I hope you are, but let's do a little review, okay? So compose has 3 phases, although they're more like 4, like the 4 on my shirt. But according to the docs, there's 3 phases to how compose goes from your composables to pixels on the screen. So the first is composition, and composition is when all those @composable annotated functions of yours get called. And what happens is when these functions get called, that is the process of determining what actually will be in the UI. And when these functions are actually invoked and called, they create emissions, and these emissions are really just nodes in an ever-growing in-memory representation of your UI as a tree. So after that, we know what's going to be on the screen, but we need to know how big it's going to be and where it's going to be, and that's where the layout phase comes in. So the first part of that is the measurement phase, and in the measurement phase, these emissions need to measure themselves and their children and let other parents or other ancestors know how big they're going to be. And then finally, once things are measured, they need to be put somewhere, and that's where placement comes in. The elements place themselves and their child elements. And the third is drawing, where the pixels actually start popping up on your screen, but we're not going to talk about that. So the thing that I want you to remember the most about compose phases is that one of the really cool things that we're learning how to do with compose is understanding skipping, right? And where our state goes, and good state hygiene, and where to hoist things, and all these things. So there's a lot of benefits to doing that. And one of those, which is really cool, and it has to do with compose phases, is that there is a concept known as phase state reads. So you already probably know that if you have state that doesn't change, compose generally is smart enough to know, hey, your state didn't change, I can skip this composition. The granularity of that is actually quite smaller. It actually goes down to these 3 phases. So if there's some state even in layout that hasn't changed, or in measure that hasn't changed, not just composition, but those individual measure and layout phases can also be skipped, and we can use that to our advantage. So we are going to be building a layout with the layout composable. I know, big shock, but I really, really love this kind of basic layout. And that's for a couple of reasons. The main reason is just cool, and the second is that you can actually see the composition phases or the compose phases in different parts of this layout. So for composition, again, where we have all of our @composable annotated functions that we're lining up and putting in rows and columns, all of that composition happens in that content tag that you see in most of your favorite framework containers. And again, inside of that content lambda is when all of those composes are emitting and making that in-node tree representation. All right, so measure. You can actually find measure if you look inside of a layout implementation. And in that measure policy lambda, that first bit before you see the layout method down at their bottom, that's measurement. And unsurprisingly, that method that I just mentioned is where placement happens. So in the course of trying to take advantage of things like those phase state reads, it's really easy to tell, okay, well, if my state is literally in the middle of the measure policy above layout, then that state is read by the measure phase. So I just love that kind of simplicity of it. It reminds me a little bit of on layout, on measure, and on draw, but a little better. So I have a question. Do you want to build a schedule? Because, I'm sorry, a little too close to Christmas for that. So throughout my career, I've had this really weird coincidence of being at a lot of different jobs where I make projects where I build a UI that has a bunch of stuff in it, and that bunch of stuff is laid out along a horizontal axis that represents time. So I've done Gantt charts, I've done video editing, like a video line. I keep solving the same problem. Maybe it's destiny, I don't know, but we're gonna build a schedule today. And to build a schedule, we're gonna go to Android Studio. All right, I'm gonna ask everybody, can you see my code okay? Like the size okay? People in the back especially give me a thumbs up. Cool. All right, just shout if you need it, if you need like font size in beginning. That is not words that actually exist in the English language, but we're gonna go with it. All right, so I love working out, and my dream actually is to take my schedule expertise and build a fitness scheduling app for classes. So we're gonna start our schedule app today with these sessions. So the sessions are gonna be just these individual composables that represent a single class, say, and they have a start time and an end time, and additional information, class name, class location, name of your fabulous coach, and their picture, things like that. So when I first started making my schedules, I figured, okay, let's start off simple. Let's try using a row or a lazy row. Let's try to do this simply because we don't want to, always go for the hardest thing, although I have to admit I am a golden hammer type person with custom layouts, but try and be also a good engineer. So let me try a few different things. So I have an app here, and hopefully the mirroring will, let's see, let's run my app here, and hopefully the mirroring will pop up. Oh, yes, live building. It's fun, it's exhilarating. Okay. Yeah, thank you. The marketplace on plugin. I have all of the bars. I don't think I need all of them, but okay. So, oh, shoot. Okay, I'm gonna run that one more time. So I have here, this is generally what the app is gonna look like. Sorry, I need to switch out a few things. Okay. Oh. All right, let me try one more time. So I started out with the row layout. So what's really interesting with the row layout is that, and the lazy row in fact, is that the logic of row is very particular, right? So the way that row works is that, whatever composables are inside of row are laid out consecutively, which is not necessarily a bad thing, but if you look at, say, this preview of my schedule app, which I'm still trying to build, you can see that, well, unless my session data is very specifically one after the other, I'm gonna have gaps, right? And so that's a little bit tough with the row limitations, since it tends to just like not really care where things go, just that they go one after the other. So what can I do about that? Okay, this is actually, okay, great. So what I had to do, and if I wanna look inside of, say, my schedule row track, so this is that implementation of the schedule as a row. You can see what I had to do is do a bunch of processing here where I say, okay, well, here's the start time, and here's my first session, and it ends here. The next one starts there, so I'm gonna make a spacer. So I basically create, non-existing element spacers to create, be able to position things correctly. It's not great, but it works. But I will tell you that even, I know we always want to say don't pre-optimize, but there are some disadvantages to doing this. So to show you those disadvantages, I'm going to actually start up Layout Inspector, open that layout back up. So actually, this might be hard to see, but if you drill down in Layout Inspector all the way down, and turn on rotation and get the mirroring to, there we go. So if we drill all the way down and carefully hold our phone so it doesn't rotate again, we'll see here, here's my schedule row track and here's my schedule lazy row track. So another thing that I have on this schedule is a sort of ability to zoom. I'm an engineer, I don't have a cute way of calling it, so I just called it DPs per minute, as in the density, independent pixels per minute for rendering. I'm sure there's probably a better word like zoom or zoom in or zoom out for that. But as I pull this slider, the density that I'm using to render minutes is changing, so you can see that the actual size of the sessions are kind of increasing and decreasing. So as I did that, we can see that here is my recomposition count. Now, I know it's hard to tell, but basically that first column, if you see like the white light numbers right here, those are recompositions. The third column are compositions that have been skipped. So as you can see here, as I'm moving this bar, those numbers are just flying up. Now, that's not necessarily a bad thing. There's not really much going on here, but we really do want to be able to skip recompositions if we can. And the kind of crazy thing is as I mentioned, in those compose phases, if the state for a particular phase isn't changing, it should be able to skip that state, right? So if I just move this bar a little bit, really composition's not really changing. The things that are in my screen here haven't changed. There's none that are disappearing and reappearing. They're all there. So why is it recomposing? Well, if I go back to the actual code, I'm doing all this logic, I'm measuring things, I'm setting widths, I've got these spacers. I'm basically doing more or less measure and layout, right? I just kind of doing it janky-like through a spacer. But within these platform containers like Row, that content, that place where we put all our lovely composables, this is all composition. So really state that I'm using for measure and layout is getting read and written in composition. So while that's not necessarily a bad thing, and again, don't pre-optimize, this is something that we can maybe change for the better. So to do that, I actually have a different implementation. We're gonna go back here. I am going to, let's get rid of lazy layout. Actually, there's one other thing that's kind of interesting that's gonna be relevant later. So with lazy layout, or lazy row rather, I try, and what I want is my row height to basically fit the tallest element, right? I just want to be able to fit everything in, nothing fancy. What's interesting is that with lazy row, because it's lazy and it's efficient and it doesn't compose things that are off the screen, it can't refer to the measurements of those things that aren't composed. So if you look at that lazy row implementation, as I scroll, if something taller pops into view, you can see that the height of the row is changing. Now, I've had this problem. I basically was like, hey, can we fix the height on this? Okay, cool, we'll just call it and put it under the rug and leave it there. But again, you might not always have that option to fix the height. So it's always going to be a trade-off, right? Do I need the performance of lazy row? Do I need very, very specific behaviors? It's always going to be a discussion with you and your designers and your manager and maybe your inner self late at night when you're up late at night trying to figure out how this works. But there is other options, and I want to show you one of those, and that is by doing, instead of any of the out-of-the-box containers or layouts rather, is my own personal layout implementation, my own custom layout. So here you can see the layout tag here. Now I'm going to rerun this now that I've enabled it, and I'm going to show you that, number one, it looks similar, okay, and its scrolling looks pretty good. And actually what's really great about this is we can see those phase state reads at work. So I'm going to turn Layout Inspector back on. I'm going to very deftly, once ADB, come on. I will very deftly and quickly, and with much speed, go into my layout. And so the bottom one here, that bottom row is the layout, my custom layout that I created to implement the same schedule. I'm gonna drill down, drill down, drill down. Okay, we can see my custom layout here, and you can see my schedule row track. Now, say if I pull, can you see it here? Okay. Okay, now, as you can see here, I'm pulling the slider, so I'm changing that DPS. So that will cause the schedule layout track to recompose, right? Because the content is widening and narrowing with that pull. But what's really cool is that all of those sessions, so up here in the schedule row track, if I drill in, all of those individual sessions that aren't being recomposed, that don't need to be recomposed, are being recomposed in the row. But if I go down here to my schedule layout track, which is my custom layout, you can see that all these sessions get to skip those compositions. Amazing, right? And all it has to do is just essentially it's picking the right place to do things, and I just think that's really cool. Now, another thing that we can do with schedule layout track or my custom layout track or just layouts in general, custom layouts in general, is, a couple of different things. Let me take you through the code of this to show you that it's not too hard. So here is my schedule layout track, my custom layout. And here is the composition phase, and it's actually a lot simpler now. What's really cool is I kind of like how it's gotten really abstract, right? I'm literally just telling, my layout composable here. Here's the stuff you need to compose, and that's it. There's not a lot of additional information or calculating of things. So I have here my session composable. I have here a key. I'm iterating through a list of sessions. I am doing a very disgusting, gross thing by trying to associate the session data object with the session composable by sticking it in the layout ID. OG Android devs that used to stick all kinds of data in the tag. Raise your hands, maybe. I'm not going to judge because that was me. We really shouldn't do this though, but I will fix it later, I promise. So now we're going to go down to the measure policy, and let's just go step by step through this. Okay, so we have the measurement phase. I am converting my dips per minute to pixels per minute. So what happens is, at the top of this measure policy, you're going to get this value called measurables. So this measurables is a list of the emissions from all your composable functions, okay? These are the things that are actually going to appear, and they need to be measured. They are measurable. And so what we do is we measure them. And so I'm taking my disgustingly packed into the layout ID, really bad of me, session data. I'm pulling out the duration of that session, and that duration is what's going to kind of definitively size or give the width of my session composable. So I pull that out, do some multiplication, and then I have the width of each session. And before I can actually officially measure that session, I need to use constraints. And so constraints are basically, they're not too unlike layout parameters in the old view system. So they basically define bounds or lack thereof for the width and height of components. And the one thing is, like, don't make them negative, it'll crash. But you can have constraints like this, where you have, say, a min to 0 and a max of infinity, basically meaning that the width and height are unbounded. You can have something like this, where it's a little more, nuanced, a min width of 400, but, any bigger than that's fine. And then, of course, more kind of rigid constraints. For this particular, layout, I know exactly how wide they have to be, and I generally am like, okay, whatever, be whatever height you want to be. So I'm actually taking the parent constraints, I'm copying them, and to fix a width with constraints, you basically just set the min width and max width to the same quantity, and then I measure them. I call on each measurable measure, and then pass in these constraints, and it will figure out how big it can be within those constraints. All right, so now I've measured these. So these measurables are actually getting mapped up here into this placeables list. So once things have been measured, they can be placed, so they generate placeables. And those placeables, sorry, ooh, that's a surprise for later. Those placeables end up down here in the placement phase. And what we do have to do, though, is determine the actual width and height of our layout, which we do here with content width and content height. I'm basically saying, okay, the total span of time of my sessions is this width, and the height is basically going to be the max, like whatever the max height of any given session is. I put those into this layout method, and then I call that lovely, calculating the x coordinate from the start time, and then at the very end, for each placeable, I'm calling place relative. There's, I think, place absolute, or place absolute? But, because I always use place relative, and that's nice because it actually respects right to left to right direction. So I think you should always use it. So that's why I don't remember what the other one is. But yeah, it's pretty simple, right? I mean, it's not nothing. It's not just some modifier you stick in and everything's done, but it's really straightforward. And the really nice thing is that, the state is only read where it needs to be. So I get that nice phase state reads. So another thing that this can do is that we can solve that problem of, with the lazy row where, it needed to measure everything, but it couldn't. So there's a rule that you need to know if you're going to dive into these things. And that's it. And that is that for every frame, every composition, every recomposition, every kind of round of all those phases, you can only call measure child once for each measurable. If you do more than once, it's going to crash and you'll be sad. Believe me, I tried. So, okay, that's fine, but how can we do this situation where, okay, we need to measure everything, find out the largest height item, and then, okay, well, you just told me I couldn't measure twice. What do we do? What we can do is we can kind of pre-measure or get a kind of guess about what it is, and that's through intrinsics. So intrinsic are nothing more than kind of going to a component and saying, hey, component, I'm going to give you some min or max width. Tell me how high you need to be to render your content, or the converse, which is like, hey, if I give you this min or max height, like what width will you be? And so that's what we can do. By kind of leveraging this, we can go ahead and use intrinsics. And since, for my sessions, I know exactly how wide they have to be, right? They're just some duration. So I can use intrinsics in that way. So I want to back out just a little bit. I'm going to switch around some code for you here. And I'm going to hide the stuff at the top. All the way to here. Boop. Okay, no red squigglies. Boop. Run anything. All right, and we open that back up. Okay, so now I have my, sorry. All right, don't have the inspector for now. Okay, so I go back here. You can see here now I have my layout implementation, my custom layout at the bottom. I'm gonna zoom in a little more for you. And scroll down. And as you can see here, I was able to use intrinsics to actually do a pre-measure, and then now everything can be easily the same height, and I have no crashes from measure. All right. What's next? Well, this is all well and good, but what if, say, now this is a pretty simple, use case, right? I don't have too many classes, and everything's kind of fairly nicely behaved, but what if I did this instead? I'll go to my demo source. I'm going to change it to, let's change it to the third one. Let's get crazy. All right, and then we're going to run that again. Oh, okay. We're going to run that again. And say my data was a little bit different. All right, say my data looked something like, let me arrange just decided to die one quick. Okay, there we go. All right, say my data was a lot more complex. It's showing my device, but it's not. Okay, there we go. All right, say my data was a lot more complex, right? Okay, so if I look at, oh dear. So if I look at the bottom row here, right, I have a lot more data. It's a lot more dense. There's a lot of different places we can take classes in this gym. The data's overlapping. Now, if you look at the row manipulation, we can see how this is just basically invalid. Because row can only do things consecutively, it cannot handle overlapping data. And the layout implementation does handle it, but it's basically unreadable. So what can we do? Well, what we can do, and I'm going to see if I can reset this up, is what if we just separate things out? Let's not, run everything. Let's not lay out everything in the same track. Let's have multiple tracks and see how we can do. So a kind of initial implementation of that might look like this. So each one of these locations now, so I separate out my data by location. So I have a map, and each key is a location name, and then each one has a list of sessions in that location. So this looks pretty good, right? So I have my data separated out. It looks like it's rendering correctly. Now, instead of having one layout that scrolls, I now have several. So how would I coordinate the scrolling of all that? Well, the first thing I tried, and I did try this at a project, and I was very sad when I did try it, is I could do something like this, all right? So I have I have a track scroll state, and I have this loop here that's going through my map of sessions. I'm generating the session layout track, and I'm giving each one the exact same scroll state. So what does that do? Well, if I start playing around, it looks okay, but I'm pulling on that second track. You see how the overscroll only happens for that one? And what's more is if I go down here and scroll, you can kind of see that there's actually some truncation of the data. There's data that's cut off. And I think I didn't bother looking because this just wasn't working for me. But I think what happens is basically because this one is the last one to grab the track scroll state, it actually is setting the min and max scroll. So it cut off all the rest of the data. So, okay, well, that's bad. What can we do? So this is a legit problem that I had at work with one of my schedules. And I was like, well, how do I do it? And I didn't solve this on my own. I actually asked Adam Powell about this later. And he said, yeah, sure, you could try to share the scroll state. But really, scroll state is meant to be a single source of truth for a single scrollable component. And he was like, well, you can write your own, gesture, a state machine if you want. I was like, oh, that sounds really hard. I actually ended up finding an answer that Adam had given to someone else. Eric Hellman, are you in the room? No, that's okay. So Eric asked a question, and I think he was doing a TV guide or something. And Adam Powell, this idea is not mine. This is 100% Adam Powell's idea, was to kind of change the perspective on the data. So this is what I actually did for work. It worked out really well, and I'm so happy. So I have here this theoretical schedule, right, with a bunch of things in it. Okay, and when my component scrolls, right, there's a notion of an offset. So there is like the measure and laid out like positions of the stuff in my layout, but then there's also this other state that comes in that kind of offsets it. What if we throw all that away and say, okay, when we're scrolling something on the screen, really we're just kind of rendering a portion that is visible to the user. What if we take that idea and make that our central kind of state? And instead of thinking, okay, here's my layout and here's like a scroll offset into it, let's just call the visible area, a viewport and defined by a start time and an end time. And that viewport becomes the central state, driving my layout. It becomes like, I've been reading a lot of docs, and a lot of them are like talking about a single source of truth, but it becomes part of that single source of truth that the layout can then communicate to the children. And so if I go with this route, what I can do is that rather than thinking about scrollable state, I can just think about shifting the viewport. So what I do is when I scroll, for example, instead of, again, an offset, I can just shift that start time, end time, keep the duration of the same, and just shift. And it looks like the schedule is moving under the window, but theoretically, abstractly, it's the viewport moving over the content. It's really just a little bit of a different perspective, and I absolutely love that. And what's really cool is that because this is now a different state and perspective, it becomes more ingrained in the layout data or the layout like logic and state. And I kind of love that because with Compose, right, we're trying to like reduce surface area of coordinated state and syncing state and just trying to make things simpler, right, and easier to manage. And I just feel like this really goes with it. It was such a really cool idea, and I was so happy when it worked. So yeah, so if we can just figure out a way to get rid of scroll state and just say, okay, part of my layout is just to manage this viewport. Theoretically, we've got the top where the viewport's waving around, but the bottom, the user just sees scrolling. And I absolutely love that. So, and then, of course, if the user actually is scrolling, we'll just translate that to the viewport. So how do I do that? It's going to be step by step. Oh, Lord, it's already 11:44. Okay. So we're going to add a couple of things to our layout. We're going to add some things that I think are really cool tools that you might have seen by doing Compose. We're going to talk about scopes, and we're going to talk about custom modifiers. You probably have played around with this a little bit. So all of your favorite, or not favorite, I guess it depends on how you feel about things, feel about particular layouts. A lot of your framework layouts have this scope, right? So you look at the content slot, if you look at the content slot, you'll see this lambda, right, this function type. And the function type often for these framework containers has this scope as like the context receiver. Well, what is this? Well, it's a scope. It's basically a region that creates a context. And within that context, certain data and APIs and functionality is visible. It's scoped there. And if I actually go into box scope, usually it's an interface. And as you can see here in box, we don't have too much in the scope. We just have two modifier factories. There's no state here. And that means that in the actual implementation of scope, because box scope doesn't hold any state, it's really simple. It's just an object, it's a singleton. That's important. Now, if we look at something like box with constraints, so box with constraints is the variant of box where it actually passes some state to children. It can hold its max, it can hold like, the max width, min width, and the other ones for the height as state and pass that to children if the children need to measure and lay out, as a function of what its parents' width and height is. So that's state. And if we scroll down to the scope instance, we can see that wrong one. This one. We can see that, okay, because this has state, it's now a class. It cannot be a singleton, right? Because it has to be able to hold that state. All right, so let's take those and let's build our own scope. So I have here a schedule scope. So I'm kind of basically copying. I have no good ideas. I'm just copying either from like Adam Powell or the documentation or the code itself. What do you do? All right, so I do have some state I want to hold in the schedule scope. The viewport and the minutes per pixel, that density, that zoom. Okay, we'll call it a zoom. I like density. So that's my state. It's variable, it's mutable. And I do have my own modifier factory method here, time range. So I've marked this as stable, and this is another important concept to be aware of is stability. So You'll probably see these annotations. You've probably read some really great articles, maybe by Ben Trengrove, about stability. So basically the idea is compose will skip recomposition when it knows for sure that your state hasn't changed. So it could be as simple as, hey, this is a data class, it doesn't change, it knows for sure. But there are times when compose maybe just won't be able to guess. A good example of that is like list, like the list interface. We don't know actually there's a mutable implementation under that, so compose will be like, nah, man, we're just going to recompose it and see what happens, and that's why we have immutable list collections. So stability is more just the idea is like, okay, is a type stable, which is either it's immutable or it actually it will specifically notify compose when it changes. So compose can very specifically say, okay, you've changed or you're not. It knows for sure. If it's unstable, if there's any unstable like parameter into composable, it'll just recompose. That's the safest thing, right? Because you don't want to lose data. So the safest thing is just to recompose. So this is important here for the schedule scope because I am holding state. And by the way, if you have the originally Twitter but now Slack compose linters, if you say sometimes write a composable and you try to be cute and have an extension function out of another method, if you do it wrong like I have, sometimes you'll get the Slack link complaining at you like, oh, like extensions on an unstable object will recompose. That's what this is referring to. So I need to make this stable. Now, what's the implementation look like? Okay. Now, I'm going to get fancier, and again, I'm stealing stuff from the APIs. I will just give a caveat that I'm doing some stuff that's probably fancier than I strictly need for this example, but I think that there's so much flexibility in layouts that I just kind of wanted to show you kind of just some of the crazy stuff I'm doing. Maybe the Googlers in the front will start staring at me really weird and throw things at me. Please don't, guys. But I just think there's a lot of flexibility and cool things to learn about how the framework does things. All right, so I have here my schedule scope implementation. It implements the interface. I've got my two state variables here. So my scope, in fact, is stable because these two states will notify compose of when those have changed. And I have here my time range modifier factory that creates an element. Okay, so let's dive into custom modifiers real quick. We probably all have written slightly simpler custom modifiers where it's a factory method and we're just chaining together a bunch of modifiers that we like. Well, if you want to do your wholly own homegrown modifiers, there is a really great API for it. It's the modifier.node API. It's a little bit, for me, it wasn't the most intuitive thing to get into, but there's basically two parts, okay? So whenever you create a modifier, right, there's some behavior that you want to implement, and there possibly is some state that goes with that behavior. So the first part of the modifier.node API is the modifier.node. This is a longer-lived, it survives recompositions, possibly state holding, a logic executing portion of that API. And it's mutable, so basically it'll sit around, wait for updates to the composable, and then update the state, and then execute logic if it has to. Now, the component that does the job of hey, notifying that node it needs to change is the time range, is the element portion, the modifier node element. And it's short-lived. It gets created every time you have one of your modifier function calls. It creates one. And then it does the job of either creating a node or updating a node if it has to. So here, for this modifier, and I'm going to fix that nasty kludge I did, I actually want to be able to have a modifier to specifically specify a start and end time for a composable in my schedule, rather than stuffing a whole bunch of object data in there, and so I can be more kind of specific and clean with how I distribute the data. So that's my custom modifier. We'll go back. And so that's that. So you can see here, here's my factory method, and here's it creating the time range element. So in terms of scope, right? So I have my scope object here. My scope is going to be this context, right, where certain things exist in it. And part of what's going to exist in it is my viewport. So that will now become my source of truth. And the scope will be the kind of place where you go to get the viewport. And along with that, the minutes per pixel. So how do I, where does the scope live, and how can what's one way that I can kind of make it come to life and have it kind of be used inside of my layout? So I kind of copied some of those favorite rememberables that you probably have now in Compose. And I have this remember schedule scope method. It takes in a viewport as a parameter, and it implements it uses remember savable so that it respects configuration changes, always respect configuration changes. So on initial composition, it'll run this init, and it will implement, or it'll instantiate rather, my schedule scope implementation and pass in that initial viewport. So what's really cool is that because it's a composable function, this will get rerun when the containing scope gets recomposed. So on subsequent recompositions, this init will not be called, but this also will be. And so that will allow me to keep that same scope instance, but just mutate the data on it. And there's a lot of ways to do this. I didn't have to do it this way, but I kind of like the idea of having the scope be a little more fine-grained about the state it hands out, rather than being this big monolithic thing that just, in the stream of data that comes in, just, the scope and you have everything with it. I kind of like this idea of being a little more fine-grained. This syntax was really neat. I found it in remember updated state. It's not exactly like this, but I just thought it was really cool. Again, nothing that I'm talking to you about today is my own cool ideas. It's just really cool shit, pardon me, I found in the APIs and ASP. All right, so we have our remember schedule scope, and let's see where we use it. So, okay. All right, so here inside of this schedule, the schedule is a layout, a custom layout, and I'm calling my remember schedule scope. Now, I do have viewport as a parameter into this, and what's really cool is that if I say wanted to hook up that slider bar that I had to, say the viewport density, I can do that and allow that state to be hoisted, but it still kind of coordinates with that scope. Okay, so I have here. So here's my content inside of my layout, composable. So inside this content, here I have that scope. So schedule track is my kind of new, more like location-based track. And I have the scope object that I had earlier, and I use it as the receiver when I call this composable. And it's really neat because, for scope, there's a lot of things that you can do with it. You can actually kind of define, a certain place where your composables get used. So if you think about, say, box with like match parent size, or if you think about row and column with like weight, those modifiers can't be used anywhere else because they are scoped to their scope. And so it's a good way of kind of like, also like encapsulating your logic a little bit, and also, again, acting as that single source of truth for the viewport. Okay. What else I want to talk to you about with the time remaining? A lot of this is, if you look inside the schedule track, a lot of it is samesies. The measurement phase doesn't look too unfamiliar, and neither does the layout, and I'm going to run that one more time. Oh, I did want to talk about scrolling. Okay, so the whole point of this thing was that I had trouble coordinating scrolling between all these different tracks, and I wanted to have a cool view, a different framing that's like an intentional pun because of viewport frame, into my data, or into my, the state that drives my composable. So in order to get that really cool scrolling abstraction implementation, I have this scrollable modifier. It's horizontal. So what I need to do is translate a user scroll into time. So whenever you use remember scrollable state and you're implementing the consume scroll delta lambda, you're going to get back a lot of deltas. And I found that it worked. It looked wonderful. It looked better visually if I kind of buffered that delta and kind of collected some scroll before I got to a certain size and then translated it. So that's what the scroll to consume is. But the interesting part is here. So I have these delta minutes, and I had my viewports. Let me show you the viewport really quick. Is right here. So schedule viewport. Right, there we go. It's right here. All right, here's my schedule viewport. This is that, again, that window, and it has start time, end time, and then a min and max for, just for that set of data. Okay, and I also have all these operators that I can do just shift by. So if I wanted to say just have a really nice operation for just shifting that viewport by some minutes, I have that. I have things like scaling by if I actually wanted to do a proper zoom in, zoom out. So that's what all that is for. And then so inside my scroll, what I'm doing is taking that scroll, I'm using my density, minutes per pixel, turning it into minutes, and then using my operators to shift that viewport, write it back into the scope, and then, of course, do a callback to let anyone else know, listening to the viewport, that it's changing. And we'll just go back to the mirroring real quick. All right, and running thing. And if you can see here, oh wait, wrong demo. It works, I swear. All right, here we go. Okay, so this is that one. And as you can see here, it scrolls all together. It actually even has a little bit of the velocity to it. It's not like a static pan. It actually is kind of, taking advantage of the scrollable, but being able to coordinate. And that's all through my viewport. And here we go. We even have like the density. And just to show you, I did all this work. Am I actually still being fairly performant? I'm going to just go down here really quick. Drill down, drill down, drill down. Here's my schedule. Here's my layout. Here are my tracks. Here are some things in the layout. And as you can see here, as I'm even moving around, like the compositions are getting skipped at the track, and the sessions are like, yeah, whatever. Just, sure, do what you got to do. I'm just chilling here. So I just think those are really cool tools. I know I'm already way over. I really appreciate y'all staying. But I think there's just so many wonderful things that you can do with custom layout. And a lot of it is just getting used to it. And I think that with Compose, there are so many wonderful tools. And I just wanted to show you real quick. So you've probably heard of look-ahead layout or look-ahead scope, where if you have a layout or you have some items in a layout and they switch to another layout, it gives you the opportunity, or rather the layout, an opportunity to look ahead, understand what its final position is, and animate between them. So what I did was I actually now have 2 layout modes, because before everything that was overlapped was still kind of overlapping. I have an overlapped mode and a staggered mode, and that was my favorite part. So I basically was able to use look-ahead scope with this custom layout. And as I toggle between the two, it really takes advantage of that look-ahead scope to animate between the two. Now, the reason I bring this up is not just because look-ahead scope is pretty freaking cool, is that because if you look inside the implementation for it, which is a custom modifier, you'll start to see a lot of stuff that we've been playing with. Placeables, measurement, it all kind of ties together. So I just want to say, I know for view systems, custom stuff was really intimidating and awful, but at times I still loved it, but it was awful. But now with Compose, there's a very coherent story that we have with the phases, with state, with managing it, with composition and skipping them, and even with animation, with this beautiful multi-layered animation that we have that is all straight driven. And I cannot, share enough my enthusiasm and my excitement about being able to do these things. A lot of this was just figuring out how to do it. And the code, this is a lot, but a lot of my custom layout code was not that long, and I would argue even easier to understand rather than having row, column, row, column, row, column, and then hoping you remember what everything was. I love the intention, and I love being able to frame, the state in a different way and really take control of it. I just think that's so exciting. Thank you so much for staying and hanging out with me, and while I geek out about custom layouts and show you a bunch of stuff that I didn't do, but someone else did is really awesome. I'm Huyen Tue Dao. I will have the slides and code up. But yeah, thank you so much, and have a good lunch, and enjoy droidcon.